Great! We've made excellent progress so far. By now, you know a bit more about Python's syntax, about if, elif, and else statements, and about functions. In this section, we'll cover an important topic for Python programming: lists. So, what is a list? A list is a type of sequence of data points such as floats, integers, or strings. Therefore, understanding lists relates to your ability to organize data, a crucial skill in today's labor market. Moreover, you'll see Python creates a friendly environment for dealing with lists. Assume you wanted to create a list called participants that contains the names of John, Leela, Gregory, and Kate. Follow the rules about creating a generic variable, but be careful about two things. Place the strings within square brackets and make sure you use quotation marks. Precisely. These brackets indicate the elements inside form a list and not some other type of a sequence. Good. We see the participants list has already been prepared. Am I going to be able to extract the name of one member of the group? Of course I can. Do you remember how we extracted the letter D from Friday? Using brackets after the word Friday. The logic here is the same. I'll write the name of the list, and in brackets, I'll indicate the position corresponding to the name I am interested in. It is important that I don't use parentheses or braces. For instance, let me extract the name of Leela. As programmers, we start counting from 0. So, 0, 1. 1 should be the correct position. And it is. For the sake of argument, in such a situation, a computer scientist might say you have accessed the list by indexing the value 1. This means you have extracted the second of the elements in this list variable. Okay, nice. In addition, there is a way to get to the last element from your list. Start counting from the end towards the beginning. Then, you need the minus sign before the digit, and don't fall in the trap of thinking we begin enumerating from 0 again. To obtain Kate, we have to write -1. To obtain Gregory, we need -2. Okay, now let's study a key feature of lists: replacing or deleting items in a list. Let's assume Kate had to quit for some reason, but Maria could replace her. Here's what we can do. Across the value at position number 3, which currently refers to Kate, and assign it with the string Maria. Let's check if our intuition was correct. 100%. Amazing! Another scenario. Unfortunately, Gregory got a better offer somewhere else, so he quit as well. There's nobody to replace him, but we must adjust our list accordingly. The del keyword could deliver the required result. Type del, then correctly index Gregory's position by typing participants2. And voila! Important to note is that deleting an element changes the indices of all successive elements. After removing Gregory, Maria's position shifted one place to the left and is now at the second position. There is no element at the third position. In our next lesson, we'll learn what to do if we have to add a new person to our list. Thank you for watching. So, a new name, Dwayne, needs to be added to the participants list, and we'll use a method called append. Think of the terms method and function as interchangeable, because in practice, methods work quite like functions. However, the technically correct term to use in this situation is method. Here is the syntax that allows you to call ready-made built-in methods that you do not have to create on your own and can be used in Python directly. After the name of the object, which in this case is the participants list, we'll put a dot called a dot operator. The dot operator allows you to call in or invoke a certain method. To call the method append, state its name, followed by parentheses. To insert the name Dwayne in our list, we must put the string Dwayne in inverted commas between the parentheses. After we execute the cell, we should have Dwayne added to our group. Shift and Enter. Correct. Great. Remember this general structure because we have to comply with it if we wish to call any existing method in Python. Alternatively, the same result can be achieved by using the extend method. Let's invite George and Catherine in our group. First, let's invoke the extend method. Okay, good. This time, within the parentheses, we'll have to add brackets as we are going to extend the participants list by adding a list specified precisely in these parentheses. Execute through Shift and Enter, and you'll have the two pieces attached: the initial participants list and the extension. Thus, you still manage to enlarge your original list, right? A couple more things before we close this lesson. First, let me show you that lists' elements are directly treated as string values. After printing this command, we can see the first participant in our list is John. It was not necessary to put any quotation marks around the participant's element to do that. Perfect. Finally, the len built-in function counts the number of elements in an object. For instance, if our word is dolphin, this function tells us it is composed of 7 letters. More importantly, though, this same function can be applied for obtaining the number of elements in a list. Applied to the list we have here, it shows us the list entails 6 members. Awesome! To summarize, observe how a built-in function takes the object participants as an argument, while when we are calling built-in methods, they are applied to the participants list with the help of the dot operator. The different syntax helps you distinguish between the two. By the way, lists can be sliced too, but more on that in our next video. Thanks for watching. In this lesson, we'll introduce you to another very important concept: slicing. In the future, when working in Python, you'll typically have to deal with data that is quite big. Many of the problems that must be solved will regard a tiny portion of the data, and in such cases, you can apply slicing. Imagine you want to use the participants list we saw earlier to obtain a second much smaller list that contains only 2 names, Leela and Maria. In Pythonic, that would mean to extract the elements from the first and second position. To access these elements, we will open square brackets, just as we did with indexing, and write 1:3. The first number corresponds precisely to the first position of interest, while the second number is 1 position above the last position we need. In our case, 2 plus 1 equals 3. Correct. We can say we just sliced our participants list to obtain a new one with the names Leela and Maria. I know this piece of syntax seems a bit strange, but it is not that illogical. Let's get the first 2 names from the list, John and Leela. In this case, you don't need a number at the beginning, and you can start by typing a colon. Okay, so by typing :2, we get exactly the first 2 elements. Very good. And how can I obtain the last 2? One way would be to indicate the 4th position, corresponding to George, and leaving nothing after the colon. This would mean we will extract all the elements from the 4th position included to the end of our list. Another way to obtain the same result would be to put a minus sign in front of the number 2. Thus, Python will revert the direction of counting, starting from the end towards the beginning. How many elements are we asking for? 2. Let's execute. And here's the output. We've obtained George and Catherine in a new list. Perfect. Okay, let's check out some additional methods that can be applied to lists. Assume you know Maria is in your list, but you don't know her position. In other words, you'd like to obtain the index of the element Maria from the participants list. Just call the index method and indicate the string variable of interest in parentheses. The machine tells us Maria is in the second position. And it is. The next functionality is an interesting one. I will show you it is possible to create a list of lists. My goal will be to create a list called Bigger List, which contains the participants list and a new one I will call Newcomers. Let the latter enclose the names of Joshua and Brittany. Shift and Enter. Okay, we created Newcomers. All I need to do in the next cell is write the name of the variable Bigger List and cite within brackets the names of the lists I would like to include. Let's verify if this works. Yes, it does. The two lists are shown in the suggested order. Great! An important method that could order the names of your participants in alphabetical order is sort. As you can see, after applying it to our list, Catherine comes first and Peter is last. If within the brackets we say we would like the names to be sorted in a reversed order by stating reverse equals true, Peter would be first and Catherine last. Naturally, if our elements were sheer numbers instead of people's names, this method would function without any problems. Observe how, in this example, I sorted the numbers from 1 to 5 from the smallest to the largest. And here, from the largest to the smallest. Wonderful! This was a very important lecture. Stay tuned for the next one, where we will discover what is a tuple. Tuples are another type of data sequences, but differently to lists, they are immutable. Tuples cannot be changed or modified. You cannot append or delete elements. The syntax that indicates you are having a tuple and not a list is that the tuple's elements are placed within parentheses and not brackets. By the way, the tuple is the default sequence type in Python. So if I enlist 3 values here, the computer will perceive the new variable as a tuple. We could also say the 3 values will be packed into a tuple. For the same reason, we can assign a number of values to the same number of variables. Do you remember we went through that a few lectures ago? On the left side of the equality sign, we just added a tuple of variables, and on the right, a tuple of values. That's why the relevant technical term for this activity is tuple assignment. In the same way we did for lists, we can index values by indicating their position in brackets. That's why we obtain the first number from the tuple x, namely 40. In addition, we can also place tuples within lists, and then each tuple becomes a separate element within the list. Tuples are similar to lists, but there are some subtle differences we should not overlook. They can be quite useful when dealing with different comma-separated values. For example, if we have age and years of school as variables, and I have the respective numbers in a string format, separated by a comma, hence the name comma-separated values, the split method with the proper indication within the parentheses will assign 30 as a value for age and 17 as a value for years of school. We can print the two variables separately to check the outcome. Everything seems to be correct. Awesome! Last, functions can provide tuples as return values. This is useful because a function, which can only return a single value otherwise, can produce a tuple holding multiple values. Check this code. I will input only the length of the side of a square, and as an output, the squareinfo function will return a tuple. The tuple will tell me the area and the perimeter of the square. This is how we can work with tuples in Python. Thanks for watching. Now that you know what lists and tuples are, you will more quickly understand what dictionaries are about. Dictionaries represent another way of storing data. Each value is associated with a certain key. More precisely, a key and its respective value form a key-value pair. In this example, we have 4 keys. Different names of animals are attached to each one of them. Pay attention that neither parentheses nor brackets will work in this case. You need curly braces. After a certain dictionary has been created, a value can be accessed by its key, instead of its index. K1 can be used for cat, while K3, a mouse. Similarly, as we could do with lists, we could add a new value to the dictionary in the following way. The structure to apply here is dictionary name, new key name within brackets, equality sign, and the name of the new value. The value we'll assign to key number 5 is parrot. I'll press Shift plus Enter and we are good to go. Replacing a value follows the same syntax. Just let the new variable correspond to an existing key. From that moment on, attached to the second key, we won't see a dog anymore. Ha! It's a squirrel now! You feel a list should be able to take part in a key-value pair. And you are right. Let's turn to another example. Say, only Peter works in Department 1, but 3 people work in Department 2, Jennifer, Michael, and Tommy. Shall we verify? Right. Therefore, our second element is a list. There is another way to fill in a dictionary. I'll create a new variable and we'll use empty curly braces to indicate it'll be a dictionary. I will not place any keys or values within the braces. Instead, I will assign the keys and the values one by one. And, at the end, my dictionary will be full. Quite nice. And if I asked for the center, I will see Hector's name. Let me introduce you to an interesting Python feature. If the get method gives us the name of the small forward of a given team, the machine won't display an error if we ask for the name of the coach, whose name does not take part in my dictionary. None is the default value Python returns in cases where an object does not actually exist within a given dictionary. Now, you can imagine that dictionaries could do a great job, sometimes. For instance, when using companies' names as keys and their prices on the market as values, right? Bravo! You are going deeper into programming. Remember, things will remain quite abstract unless you take the time to practice and apply what you've learned in these lessons. So, roll up your sleeves and do the exercises attached to this lesson. Thanks for watching.